All right, so we have looked at various things having to do with data, and we have talked about how to calculate our measures of central tendency as well as our measures of dispersion. Today's lesson, we're going to be talking about normal distributions, and this is related to our measures of dispersion because we're going to be using our standard deviation. So here, we want to be able to use a normal distribution to calculate probabilities, including compound events. So a normal curve is both symmetrical and bell-shaped. So here's the normal curve, a picture of it, and then the normal distributions are the numbers that you see here. And what these things mean, right down here, this line you can see has x bar. That is your mean. Then right over here, this next line, it says x minus the standard deviation. So the mean take away 1 standard deviation. Here is the mean take away 2 standard deviations. When things are normally distributed, that means that the vast majority of your data, specifically 68% of the entire distribution of the data, is within 1 standard deviation of the mean. So 68%, which would be 0.68, so you can see 1 standard deviation on each side. That's 1 standard deviation from the mean. So that's why each side is 0.34, because together that makes 0.68, which is 68%. Then, if you go 2 standard deviations away, I use a different color here, 2 standard deviations away from the mean would be those. So it would not only just be the 0.68, but it also includes both of the 0.135. So if we add all of those together, it gives us 95%. So again, this is saying that 95% of the data is within 2 standard deviations of our mean. And then finally, 99.7% is within 3 standard deviations. So if something is normally distributed, these are going to be true, meaning that anything that is outside of 3 standard deviations is going to be considered an outlier. It's a very, very low percentage of the data that is so far away from the other pieces. So we're going to take a look at what we can do with this. Example 1, a normal distribution has a mean of 22 and a standard deviation of 3. Find the probability that a randomly selected x value is in the given interval. So the first thing I always do with all of these normal questions is I draw a little picture of my bell curve. So it says the mean is 22 and the standard deviation is 3. So that means 1 standard deviation on each side, 3 above and 3 below. That's 1 standard deviation. Then if I go down 3 more, and on this side up 3 more, that's 2 standard deviations. And then 3 standard deviations would be 31 here and 13 here. So you can see those are all the numbers that would cover 99.7% of my data. So it wants to know the probability that a randomly selected x value is between 13 and 22. Well, all we have to do here is add up the values that go with those numbers. 13 to 22 is here. So that means that I've got the area from 13 to 16. So 1, 2, 3 pieces to add up. So this big one, you see the distribution, and you will not have to memorize the distribution. You'll be given this on your test. So take that, take the 0.135, which is the second one, and then take the 0.0235. So I put my decimal point there twice. If you add all of those up, you get 0.4985. And so that's going to be your probability. It did not ask for a percent, so if it doesn't ask for a percent, we're going to leave the answer in decimal form. Now, another way, which might even be simpler to do this, you know that half of the normal curve is going to be 50% or 0.5. So what you could do is you could also take the 0.5, which is the whole left side, and subtract the little tiny area that we're not talking about, 0.0015. So that would be another way to come up with the exact same answer. All right, let's look at another one. Find the probability that a randomly selected x value is at most 28. Well, we better know what at most means before we try to solve this. So at most means 28 or less. So less than or equal to. So again, at most, and I can go ahead and color on this, means it's going to be all of this. Everything that is in green is what I'm talking about. So again, you can add all of those individuals up if you want. I think it's easier to take the entire curve, which is 100%, and subtract the two that we haven't colored, which, if we look, is a 0.0235 and a 0.0015. So add those two together, subtract it from 1, we should get 0.975 would be our probability. All right, so we've calculated probabilities. Now we're going to look at a different situation. It says a company produces light bulbs having a life expectancy that is normally distributed with a mean of 1,000 hours and a standard deviation of 50 hours. So again, before I even read anything else, I draw myself my normal curve. My mean is 1,000, it said. Standard deviation is 50, so 1,050 here, 1,100 here, 3 standard deviations, 1,150. And then on the other side, subtracting that, so 950, then 900, and then 850. So there are the numbers associated with each of my standard deviations. So what percent, notice that it asked for percent this time, of bulbs will last for 1,000 hours or more? Well, this one's a pretty easy question because 1,000 hours or more, 1,000 is the mean. So 1,000 or more is exactly half. So 50%. Nothing else to do on that one. What is the probability that a randomly chosen bulb will burn out in 900 hours or less? Okay, so 900 hours or less would be those two. So if I'm looking at it, all I'm talking about is these two little pieces. So easiest to add those up, so 0.0015 plus 0.0235, which should give you 0.025. And again, this said probability, not percent, so always watch for what kind of answer they want you to give. Next, what is the probability that a randomly chosen bulb will last between 850 and 1,050 hours? So 850 to 1,050 is right here. So these two places together, that's 0.34 and 0.34, so that's 0.68. Then this one over here, if we scroll up, is the 0.135. So I'll add that. And then finally, this one right here is 0.0235. So I'm going to add all of those together, and it gives me 0.8385. All right, last one. What is the probability that 3 randomly chosen bulbs will all last between 850 and 1,050 hours? This one is different because this is compound probability. Notice it says including compound events. Compound event is when we have multiple things going on. It's not just one light bulb, it's 3, and we're asking that all of them last between that much. Whenever you have a compound event, you are going to multiply the individual probabilities. Together. So, all 3 of them to last between 850 and 1050. Well, we just did the probability of 850 and 1050. Each of those individual probabilities is 0.8385. Because there are 3 of them, you would be multiplying that times itself 3 times. So here it would be faster to just use the third power. Now again, sometimes you're going to have a compound event where the probabilities aren't the same, which means obviously you're going to multiply the different probabilities together. But here, since it's all 3 the same, we can just cube it to get our answer, and that would be 0.5895.